Go.
Hello.
Hello, Mr. Ari. Are you alright? Yeah.
Yeah.
So what did we talk about yesterday?
Oh, we talked about
What?
if two binary trees are the same.
Same binary trees, and we're using.
Go back to video 190 something.
How do we check if these the two trees are the same, A and B? How do we check it? How do we check? Do you still remember?
Color.
Yeah. How do we check it? Do you still remember?
Oh, we deficit.
The first search. Okay. So first of all, if we want to check it, then we quickly review a little bit. If A is none and B is none, what should we do? Return what? If both trees are empty. True. Okay. And okay, if A is none or B is none,
return
what? One of them is none.
false.
Return false. Okay.
Oh yeah.
If
Oh yeah.
A dot value not equal B dot value, what? If the node value are not the same, what happens?
Return false.
Okay. And then we need to recursively check what? We need to recursively check what? Same and what? We need to recursively check what? If these three, at this point, these two nodes are the same. And what do we do next? What do we do next?
We push, no, we go on the left one.
That same what? A dot
Left, B dot left, same, A dot right.
and yeah,
B
it has to
dot
be
right.
n, yeah. Same A dot right, B dot right? Yeah, this is recursive. The time complexity is O(n), right? Yeah, the space complexity is also O(n). Okay, so this is step for search. Eric, look. Okay, Eric, look at me.
Yeah.
So we compare these, yes? This is the order. If we using a breadth search, we compare these, we compare these, yeah? That's the breadth search.
Breakfast.
Okay, so let's do it breadth search. And in breadth search, what kind of data
Breadth
structure do we need to use?
Q.
Q, okay. So for example, I have the Q. Q, what's Q?
First in, first out.
First in, first out.
FIFO.
FIFO. Meaning that, okay, so look,
FIFO.
if I put a node here, that at the beginning, what should I put with the, should I initialize the Q with?
Over root.
A root, okay? So if there are two, which root? Or a pair of roots, which one?
2 roots.
Two roots. So what kind of, look, if there are two roots, this is A, this is B. So what should we put here? Initialize what kind of thing you put it in there? Is a node or a pair of node? Or what?
It's 2.
Two nodes.
Yeah.
Two nodes, and what are these? It's called
2 double-ended.
No. If I want to put the two nodes, what kind of data structure is this?
Immutable.
Immutable. What's this? This is the list, and what do you call this? This is a list, and what's this?
A bracket.
Tuple. This is called tuple. Okay. Tuple is immutable list. Okay. List. For example, I can say x equals a and b, and x equals this is y equals a and b. The difference is that if I can set it x0 equals c, that's okay. But I can't say y0 equals c. That's not okay because this is immutable, constant. Yeah, it means that when it's created, it can't be changed. Okay.
How about it's never created?
It's not that it's created. It's not changed. I mean, what's the opposite of immutable? What's the opposite of immutable? What's the opposite?
Free time.
No. Immutable. What's im? It means the
Mutable.
opposite. Mutable means the changeable.
Also, it means free time because
Okay.
you can do whatever you want.
Okay, so for this.
That's right. I was right.
Okay. Define. Let's do the define
Free
breadth
time.
search. Same. Okay. A and B. Okay, column. Okay, so now I want to use the double anchor Q. Yeah, so Q, DQ. Okay, so what should I give it at the beginning?
Root.
So I have tuple A and B, right? Yeah, look.
Yeah.
That's how you put a tuple in a queue with the bracket.
Is a tuple in a list and another tuple too?
Tuple what? Tuple in a
Is a tuple in a list?
yeah.
Tuple
Yeah.
one.
No. Great point. This is tuple, but this is not. This means the bracket parentheses called function call. This is a
So
function.
that's a parentheses.
Parentheses, but this means that it's a tuple. Okay.
Why?
Because look, if it's a tuple, you got nothing, no characters before. If it's a function then like max, remember max 1, 2. This is not tuple. This is getting the 1 and 2, which is the maximum. Okay. This is the function call. Okay. Okay. So now we have a tuple A and B here. A and B, and then what should we do? While what?
While Q.
While Q means that
there are still nodes in the Q.
where there it's the same as len Q is bigger than 0. Okay, so where there are still elements in the Q. So what should we do with this? We take the element in front of the Q. Yeah. So let's take the node. Yeah. So let's take P and Q equals no.
P.
Because we have Q here. So let's
Q.
say
What could P possibly?
Q is the Q. So let's do it X and Y. Okay. X and Y equals Q dot Y.
Why there's a dot?
Yeah, because I put two elements a tuple, so I want to take it out, put it in X and Y. So
Q dot
pop what?
left.
Pop left, yes. Because if you're not saying pop, if you just pop, what does it mean?
It'll just put anything he wants.
No, A and B.
He'll put the B.
No,
He'll put the C and D.
yeah, pop. Pop means pop right. Pop left means pop left. If you for the first in first out, we want to take the.
Why do you just if you just put a Q dot pop? Why does it do right?
Good question. Yeah, because we have pop left, and then the one you don't specify is pop right. Okay, so look, if we pop right, this is first in last out, right? We want to pop left because when we append this direction, when we take this is first in first out, right? If you first in take the last thing, it will be first in last out. It's a stack, right? Okay, so we take two elements, two nodes in a pair. So we want to compare, right? Like a depth search. If X is none and Y is none, what should we do? If the both nodes are empty, what happens? We want to what?
True.
No. At this point, remember, we just taking the node. There may be still some nodes in the tree. We want to compare, right?
What if there isn't any?
That's fine. So we don't want to ignore. So there are two things you can. You want to skip these and continue. So what keyword should we put? Continue or break? Continue.
Break.
No. Break is
Continue.
continue. What does it mean? It means that I will skip everything there and I will go to the loop again, right? Yeah?
Continue. That's a new word.
It's not a new. Okay. So if X
Continue.
is none or Y is none, okay? Remember we have these in depth search. So what happened? If one of them is none, what happened? Can we make what should we do? False. Return false. Yeah. Return false. Right? Yeah. Am I right?
Mm-hmm.
Okay. Then what should we do? We should compare what?
We shall compare
The what? We should compare the what?
value.
Value. Okay. So how? Can you tell me what to do?
We shall.
If what?
If
X dot.
left
No, the value. Not the
value.
value. Not
Y
what? Compare. Y dot value. What?
and
What?
or
We want to compare the value. Come on.
compare the value.
How do we compare? Come on. equal. How do you write not equal? If it's not equal, right?
Not equal.
Okay, what?
If x the value not equal, y the value return false.
Yeah, that's it. And now what should we do now? What should we do now? If this node is okay, then we want to do what? If this node is opposed to 1, we want to do what? We want to do what?
Go on the right.
Sorry?
Go on the right.
How about the left?
Left, then right.
Okay, left and right. And what should we do here? Q dot what? Q dot what? Q dot what? There are two things here.
Q dot pop.
We
Q
have
dot append.
append. We want to push it into
Q
the
dot
queue.
append. Q dot append.
Okay, append what?
Append left.
What left? Come on, can you write it down, please? Append what? Q dot append what?
Append the value.
We have checked the value here already. So what should we do now? You say the left and right. What should we do?
Left, right.
Okay, so what should I put here? There are two parameters. What should I put here? Think. You need to think.
X, Y.
Xy is here. What should I do?
X dot left. X dot, no, Y dot left.
And
And X dot right and Y dot right.
does it make sense? Yeah. We want to push the pair of the nodes comparison and then it will go to the next one, right? Got it? Yeah. Does it make sense? Yeah.
Yeah.
Actually, we can use the list as a stack. We can use it as a pop, and it still works. It's just the order will be different, right? But it still works. But it's not a buffer search. It's now kind of using the stack, right? We push it and we take it out, yeah. So the order of checking the nodes doesn't matter, right? Because we always pushing the pair, right? Does it matter if I check this node first or this node first?
No.
No, because eventually I want to check all the nodes, right? All the pairs,
Why
right?
did you do left first?
Yeah, good question. Because we want to do the, buffer search, yeah, buffer search. So it's better we put it top left. What's the time complexity for this one? What? What's the time complexity?
Wait.
If this is N, this is M.
M.
What? Can you stand up, please?
N. M.
What's the time complexity yesterday for the depth search?
N plus M. No. What was it?
If one tree has one node.
Max.
Max? If one tree has one node, the other tree has a million nodes.
Minimum, not max.
Yeah, minimum of n, right? The space complexity. What's the space complexity? What's the space complexity? In the worst case, the queue will be filling with what? With what?
Maximum.
Because we every time in the worst case, when we talk about complexity, we always talk about it in the worst case. We're not talking about it in the best case, right? We're talking about the worst case. So in the worst case,
It will feel maximum.
Yeah. In the worst case, let's say it's a bit tricky because as we said, this is a binary tree, right? It's a binary tree, and every time we keep pushing and then popping, right? So the node would be, if it comes to the, it'll be O n, you'll be O n plus n, right? Does it? No. I think it's just O min and n because given this time complexity, if it's different, it will be exit, right? So it will be O plus O min and n. Yeah, this is the case. Okay. Does it make sense here? Is it the same? Yeah. Which one you think is better?
from which one?
Yeah, the depth search or breadth search. Which one do you think is better? It's easier. If I give you to write it, which one you think you're remembering? Remember depth search, the breadth search, checking the two binary trees if the same.
If I have to remember one.
No, yeah, understand and remember. If which one you think? What? Come on, give me an answer, please. Yeah.
I think.
Yeah, you think what? You think what? Yeah.
I think this one will be easier for me to
Really?
Yeah, I think.
You think? It's a bit challenging.
Oh,
Come on, I can write it. You tell me what to write and I write it for you, okay?
Depth search same A and B.
You want to write the depth search or breadth search? Come on.
I think it was which one?
Which one you think you will write? This one I just erased was breadth search.
I think it was a breadth search.
Okay, so what do we want to write now?
What was it?
Well, there are two trees. I want to compare if they're equal. So
What was it?
depth search or breadth search? Which one? You pick one. Come on. You tell me what to do.
Breadth search.
Breadth search with the Q, yeah?
Yeah.
Okay, so what should we do now at the
I think
beginning?
that's easier.
Really? Okay, so how can I write it now? What do we need to declare? Q. Okay, so let's name it Q equals what?
Root.
Sorry?
Okay.
Q what? Equals what? There are A and B. Where's the root? Q what?
Q equals.
Equal what? What kind of thing?
DQ.
DQ, yeah. Come on, DQ. And then? What should we do right here?
And I think there's a tuple.
Tuple A and B, okay.
Yeah, A
okay.
and B.
Then, yeah.
Y and Q.
Y and Q. Okay. Let's call it X, Y equals what?
X, Y equals.
Do I play the toilet one?
We want to take it out, right? We want to take it out from the beginning. So what should we do?
Pop.
What pop?
Q dot pop left.
Q dot pop left. Okay, then I have X and Y. What should we do? We should check if it's equal, right? Yeah? So what should we check?
We shall check if
First of all, if both are none, what happens? If X,
X is none and Y is none
yeah,
column,
yeah,
we shall
what?
return true.
The magic key.
Oh yeah, continue.
Continue, come on.
And if X is none or Y is none, return false.
Yeah, because as long as we found a mismatch, we just return false. We don't need to continue, right? The reason we want to continue here is that there may be nodes. There may be still some nodes in the queue we haven't checked yet, right? We have to finish everything in the node, okay? And what? If what?
And if X.
Then we want to check what?
X dot value not equals Y dot value.
If it's not equal, the value is not equal, what happens? If it's not equal, what happens?
Not equal, we shall return false.
Well then, okay. And then what? And then we have complete, this is okay. Then what happens?
Go to the left and go to the right.
How can we do that?
X dot
What? We want to, wow, this is a queue. And then we take a node out. And then we want to do the preference.
append.
What dot append?
Q dot append X dot left and X dot Y dot left. I think you're doing a little bit different.
No, it's the same, okay? Then what?
And
Q
Q
dot.
dot append X dot right and Y dot left. No, Y dot right.
Okay, and at the end, we finish all the checking. And here, what should we do?
Return. I don't think you did the return.
Oh yeah, that's why I put it here. Return what?
Return true.
Yeah, because no violation we found here. Yeah. Okay, so you know, yeah, how you know it, yeah. Breakfast search, right? So can you tell me what's the sequence of we checking? This is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. So can you tell me how using this algorithm breakfast search, how are we comparing the nodes? Yeah.
So we a queue,
Yeah. Okay.
and we are doing A and B, and you're going to put the notes in.
Yeah, in the queue. No, you just tell me which order. We compare 1 and 1 and then.
Then 2 and 2.
Uh-huh.
Then 5 and 5. And then 3 and 3. And 4 and 4.
Yeah, when we compare 2 and 2, we put the 3 and 4 into the queue, yeah? Got it. So what? So Eric, look, just a little bit, just in case you forgot, right? Look, this is a queue. Alright?
Huh?
Look. 1 and 1 here at the beginning, yeah?
Yeah.
And then I take 1 and 1 out, I push what?
Push kids.
What are the kids?
2.
2 and 2, 5 and 5, right?
Yeah.
And then the next one I take what out?
You take the 2 and 2 out, and then you
Push the kid. What
Yeah.
is it what? 3 and 4.
3 and 4.
Okay, then now 5, 3, 4. You see? That's the level, yeah? 5, 3, 4, okay? 2, 5, 3, okay? That's how it works, breakfast search. Yeah, breakfast search level by level, okay? Got it? Okay, well done. You can do some special dance at the end.
Ding dong!
Okay, that's it. Bye bye.